Morning, class. I hope all are doing good. And we have started our chapter probability. So, today we will start exercise 16.1 from sum number 8 as we have discussed till sum number 7. In sum number 8, the statement says an experiment consists of recording boy girl composition of two families with two children. So, what is given here? We are given two families and with two children. That means each family is having two children, right? So we have to write down the sample space. The first part is what is the sample space if we are interested in knowing whether it is a boy or girl in the order of their births. So we have to write down the sample space according to the order of the birth, like the first baby then the second child, means the first child second child order we have to write down. And there are two families. If there are two families, okay, and in the first family it can be can be both the boys, can be both the girls, one boy one girl, like that. So it is just like, when we are discussing the sample space, how the sample space will come, since there are two possibilities only, either the child can be boy or girl, okay. So it is just like that when I am tossing the coin twice, okay. When we toss the coin once, there are two possibilities, head or tail. And when I toss the coin twice, there are four possibilities, right? And similarly here, the child can be the boy child or the girl child, right? But since there are the order we have to check, so how we will write down? The first child can be boy, the second child can also be boy. First outcome can be when the first child is boy, second child girl, okay. It can go other way, first child girl, second child boy, and it can be first child girl, second child also girl. So this will be the sample space when we are writing the sample space according to the order of birth of the children in the family. And the second part of this sum is what is the sample space if we are interested in the number of girls in the family. Now since each family is having two children only, so at the most the family can have two girls, or at the least no girl, okay. So what will be the sample space? Sample space when no girl in the family, when one girl in the family, or two girls in the family. So that will be the sample space for the second part, okay. Next sum number 9 is a box contains one red and three identical white balls. Now if white balls are identical, now sum number 9, box contains, there is one red ball and three identical. Now when the word identical has come, that means I cannot number the balls. All the three balls which are white in color, they are identical. So whenever we have identical word, we will not number the balls. All are same balls, and two balls are drawn at random in succession without replacement. Without replacement means first of all, in succession means from the box, first of all we are taking out one ball and then we are taking the second ball. It is not like that both two balls collectively we are picking up from the bag. No, first of all one ball is taken out from the bag and then second ball is taken out from the bag, and it is without replacement. That means when first ball is drawn from the bag, and before taking out the second ball, the first ball we are not putting it back in the bag, okay. That ball is already with you and then you are taking out the second ball, right? Since there is only one red ball, so there is one red ball and three white balls. So white balls W, W and W I can write down. Now we are taking two balls with succession. So what will be the sample space? Sample space can be first ball if it is red, second ball can be white, or if the first ball is white, second ball can be red, or first ball is white, second ball is also white. Now I cannot say W1, W2, W2, W3, W3, W1. No, because all the three balls are identical. We cannot make the distinction here. So there will be only three possible outcomes in the sample space. Okay, this is our sum number 9. But if we have some other statement where the word identical is not written, okay, then we can number the balls like one first ball, second ball, third ball, and so on. Okay, so the next sum number 10 is an experiment consists of tossing a coin and then throwing it second time if head occurs. Now in sum number 10, what is happening? Okay, first of all, coin is tossed. Okay, when the coin is tossed, we know either head will come or tail will come. Now the statement says we are throwing it second time if head occurs. Now whenever head is coming, we are again tossing the coin. Again head will come or tail will come. Okay, and if tail occurs on the first toss, then a die is rolled. So when the first coin is tossed, then and tail is coming, then what is happening? A dice is rolled. When the die is rolled or dice is rolled, either one can come or two can come or three can come or four can come or five or six can come on the dice. Okay, so we have to find the sample space. Now we will just whatever we have discussed, we will write down. So when the first coin is tossed, if head is coming, we are tossing the coin again. Okay, so corresponding to this, what will be the sample space? When head is coming, again I am tossing the coin. So with head can come, or with this head tail can come, so it will be H and H comma T. But on the first coin, when tail is coming, then we are rolling a die. So it can be T1, it can be T2 or T3 or T4 or T5 or T6. So that will be the sample space for sum number 10. When first coin is tossed, on head coin is tossed again. When tail is coming, a die is rolled. Okay, this is our sum number 10. Right now, sum number 11. Suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective and non-defective. Defective means capital D. Non-defective, when it is, we are writing is as capital N. We have to write down the sample space of this experiment. Now this sum is exactly same, as when we are tossing the coin 3 times, or 3 coins are tossed simultaneously, because when I toss the coin, either head will come or tail will come. Okay, when I am taking the bulb from the lot, it can be the defective bulb or it can be non-defective bulb. Same concept is there, and we are picking up 3 bulbs, or we are selecting 3 bulbs from the lot. So these 3 bulbs, all the 3 bulbs can be defective, can be 2 defective, 1 non-defective, like that. So when it comes to the sample space, it will be same sample space as we have done the very first sum. A coin is tossed 3 times. So in place of head, we can say it can be written defective. In place of tail, it can be non-defective, or vice versa. So sum number 11, I am leaving it for you people. Now we have sum number 12. Okay, sum number 12 is a coin is tossed. If the outcome is head, a die is thrown. So sum number 12, what do we have? A coin is tossed. So it can either give you head or tail. So the sum says if head is there, a die is rolled. So when head is coming, a die is rolled. Right? Next condition, if the die shows up an even number, a die is thrown again. So here 1, 2, 3, 4, 5 or 6 can come. So if 2 is coming or 4 is coming or 6 is coming, that means whenever these 3 even numbers are coming, any even number is coming, we are rolling the die again again die is rolled when even number is coming. But if tail is coming, we are not doing anything. Okay, a die, when if head comes, a die is thrown. If the die shows up even number, die is thrown again. And what is the sample space for the experiment? So what is happening? When tail is coming all alone. When head is coming, we are rolling the dice. When if 1 comes or 3 comes or 5 comes, it is ending. But if 2 comes or 4 comes or 6 comes, die is rolled again. So what will happen for 2, 4, 6? Once again 1, 2, 3, 4, 5 or 6. Any one number can come between 2, 4 and 6. And corresponding to this, when we write down the sample space of this experiment, tail if coming, it is all alone. So when head is coming, we are rolling the dice. So when 1 is coming or 3 is coming or 5 is coming, what we are not doing anything. So first I am just writing the odd numbers of the dice. Now, if even number is coming like h2, we are again rolling the dice. So it will be h2 1, then h2 2, it will be h2 3, h2 4, h2 5, h2 6. And if 4 is coming once again on the second, means when this die is rolled, this dice 4 is coming once again, all these 6 numbers can come with 4. So it will be h41, h42, h43, h44, h45, h46. And when 6 is coming, then also h61, 62, h63, h64, h65, h66. So total these will be the outcomes in the sample space of this experiment. If tail is coming alone. If head is coming, we are rolling the die. If even number is coming, again the die is rolled. But when odd number is coming, then we are not doing anything. So odd number when it is coming, it will come h1, h3, h5. When even number is coming, 2 or 4 or 6 at the second place, we are again rolling the die. So this is how the sample space for sum number 12 can be written. Okay. Now, sum number 13. The numbers 1, 2, 3 and 4 are written separately on the 4 slips. So in sum number 13, we have 1 number or 2 number or 3 number, 4 number. These are the slips. Okay. These are we have 4 slips where 4 numbers are written separately. The slips are put in a box and mixed thoroughly. A person draws 2 slips from the box, one after the another. One after the other means with succession. It means first of all, one slip is taken out from the box and then second slip is taken out without replacement. It means when the first slip we are taking from the box, we are not putting it back in the box. Okay, so first slip is in our hand or is in that person's hand, and then he is taking out the second slip. We have to just write down the sample space. So we are taking the 2 slips are taken from the box with succession. Without replacement. Okay, and we have to write down the sample space. So what will be the sample space? The first slip can be 1, second slip can be 2. When the first slip is 1, second slip can be 3. When the first slip is 1, second slip can be 4 also. When the first slip is 2, second slip can be 1. When the first slip is 2, second slip can be 3 also. When the first slip is 2, second slip can be 4 also. Like that, it can be 3 1 or 3 2 or 3 4, and it can be 4 1, can be 4 2 or can be 4 3. So this will be the sample space for sum number 13 when we are taking just two slips from the box, okay, with succession and without replacement. So this is our sum number 13's sample space. Okay. Sum number 14. An experiment consists of rolling a die and then tossing a coin. So till now, first of all, coin was tossed, then the die was rolled. Here, first the die is rolled and then the coin is tossed if the number on the die is even. Okay, so let us go to the next page. So we have some number 14. So first of all, a die is rolled. Okay, so when the die is rolled, okay, it can come 1 or 2 or 3 or 5 or 6. Now the statement is then tossing a coin once if the number on the die is even. So when even number is coming, 2, 4 or 6 is coming, then coin is tossed. Okay, then the coin is tossed, and if the number on the die is odd, the coin is tossed twice. So when odd number is coming, that means 1 or 3 or 5 is coming, coin is tossed once here, and when odd number is coming, then coin is tossed twice, right? And we have to write down the sample space for this experiment. So again, it is very simple, but here instead of first out means first coin and then you know the die, first is die rolled and then the coin is tossed. So when we are writing the sample space, first of all, let us write down all the outcomes for the even number on the die. When 2 is coming or 4 is coming or 6 is coming, coin is tossed. When coin is tossed once, it can come either head or tail, right? So it can be 2H, 2T, it can be with 4 head can come, with 4 tail can come. When 6 is coming, either head can come or tail can come, right? So the outcomes that we will have, it will be like 2H or 2T, 4H or 4T, 6H or 6T. Even number is done. Okay, and now if odd number is coming, coin is tossed twice. When coin is tossed twice, that means it can be head head, it can be head tail, it can be tail head, it can be tail tail. Okay, so with 1, 3 and 5, these 4 outcomes are possible. So how we will write down? It will be 1HH, 1HT, 1TH, 1TT. Then with 3 we will write down 3HH, then 3HT, 3TH and 3TT. And with 5 now, 5HH, it can be 5HT, then 5TH and 5TT. So this will be our sample space for this sum experiment, where first die is rolled and for even number coin is tossed once. If odd number is coming up, then coin is tossed twice. Okay, so this is how the sample space can be written. Sum number 15 now. A coin is tossed. If it shows tail, we draw a ball from the box which contains 2 red and 3 black balls. Now if you notice here, nowhere is mentioned that any red color balls are identical. So 2 red balls we can give the number R1 and R2. 3 black balls can be numbered B1, B2, B3. Okay, so what is happening when tail is coming, then we are drawing one ball from the back, and if it shows head, then we throw the die. Okay, so this sum number 15, I am just leaving it for you people. So sum number 15 is homework. I hope you people will be able to do. And the last sum, sum number 16, we will discuss now. Sum number 16 is a die is thrown repeatedly. How many times? It is not mentioned. Repeatedly until a 6 comes up. And what is the sample space for this experiment? So now what is happening? The experiment is like endless, because we are throwing the dice or rolling the dice again and again repeatedly until 6 comes up. Now again, it is all about the chance, you know. When I roll the dice at the very first attempt, it is possible in the very first attempt 6 can turn up, or it is possible in the second attempt 6 comes up, or in the third attempt 6 is coming, or in the fourth attempt 6 will come, and so on till the nth term. Okay, so what is happening? Die is rolled repeatedly until 6 comes up. This is the experiment. Okay, this is the experiment, and we have to write down the sample space for this experiment. So what is the possibility? In the very first attempt 6 can come, or it is coming in the second place. Now if 6 is coming in the second attempt, now in the first attempt, you know, it can come 1, it can come 2, it can come 3, it can come 4 or 5. Okay, so there is a possibility in the first attempt 1 is coming, but in the second attempt 6 comes, or 2 is coming in the first attempt, second 6 can be, or 3 is coming in the first attempt, then 6 comes up, or 4 6 can come, or fifth is coming in the first attempt, then 6 comes. Okay, or there is a possibility in the first attempt 6 is not coming, in the second attempt 6 is not coming, but in the third attempt 6 will come. Okay, first attempt 6 is not coming, in the second attempt 6 is not coming, in the third attempt it will come. So like that I can have 1 5 6 also. Okay, and there is possibility in the first attempt 6 is not coming, second attempt 6 is not coming, but in the third attempt 6 will come. So you know, we will be writing all these possibilities, where what we are doing, first place all other 5 numbers will come in the, and second place 6 is coming, or in the first 2 places all the possible combinations we will write down, and third place 6 we are fixing. And then there is a possibility like first position 6 is in not coming, second attempt 6 is not coming, third attempt 6 is not coming, but in the fourth attempt 6 will come, and so on. So there will be no end. The set will be infinite set. That means the number of outcomes in this sample space will be infinity. So this sample space is an infinite set where we are repeatedly performing the experiment, means we are rolling the die until 6 turns up. So there is a possibility 6 turns up at the nth in the nth attempt, and what is that nth attempt we don't know. So this is how we will end the sum. Okay, and it will be infinite set, right? That's it for this exercise, and I want you people to do all the examples as well in your notebook of this exercise, and in the next class we will discuss the next topic, so you people can complete your exercise. Thank you, students.